All right, good morning guys, and today we're going to talk about the shape of the planet's orbits as they go around the sun. So we generally tend to think of the orbits of the planets as circles around the sun, because that's how we picture it in our textbook. That's not the case. The orbit of the planets around the sun looks more like an oval. And this is called an ellipse. And the measure of the amount of ovalness is called the eccentricity. So today in lab, we're going to measure the eccentricity of the orbit of an asteroid around the sun. And remember, the eccentricity is the measure of the ovalness. So eccentricity is a unitless number. 0 equals a circle, 1 equals a line, and your ovalness will be measured somewhere between 0 and 1. So for example, an eccentricity of 0.090 is pretty close to a circle, whereas an eccentricity of 0.541 would be closer to a straight line. It would be oval shaped, like the red path that I drew there. Why do we care about the eccentricity of the orbits? So, as you can see along the outside line, that you're closer to the sun in this position and further away in this position right here. Eccentricity of orbit is also a common misconception when we think about seasons. So when the Earth is further away from the sun, we would generally think that that means the temperature is going to be colder. And when the Earth is closer to the sun, we tend to think that the temperatures are going to be warm, because that's our experience. When we get closer to a fire, we warm up, and when we step away from that fire, we cool down. But the eccentricity, the amount of ovalness for the orbit of the Earth, is actually pretty small. It'd be like having a candle on one side of the school, and you're standing on the other side of the school trying to feel its heat. You take one step forward. Are you really going to feel the difference in temperature when the candle is on the other side of the school? Probably not. To draw the ellipse of an asteroid and to calculate its eccentricity, you will need cardboard, preferably corrugated cardboard, a sheet of paper, 2 pins, a piece of string tied in a circle, a ruler, preferably one that uses centimeters, and the equation for eccentricity and a calculator. To start out drawing your ellipse, you're going to take your sheet of paper and you're going to fold it in half, the long way or the hot dog way. Open it up, take your ruler, and in the center, measure, or close to the center as possible, measure about 2 dots 2 centimeters apart. So these are called your foci. Next thing you're going to do is you're going to take your pins and insert them into the dots. If you don't have pins, you could try something like pencils, so sharpened pencils, put them in there, or maybe wooden skewers from a kebab set. And then you're going to take your string and you're going to put it around both of the pins. If you don't have string, shoelace or dental floss will work as well. Take your pen or pencil, pull the string tight, and then move the pen around so you draw your ellipse. Go slowly if you need to. It's okay if your ellipse goes off your paper on one side or the other, as long as it doesn't go off your paper along the center line that you just folded. This center line is called the major axis. And so to calculate eccentricity, that equals distance between foci divided by length of major axis. So my distance between is 2 centimeters. The length of my major axis is 21.3 centimeters. So 2 divided by 21.3 gives me this number here. We're gonna record to 3 digits after the decimal. So the eccentricity for this ellipse is 0.09, and then we're gonna round that last number up to 4.